Okay, so in this problem, we want to find the equivalent capacitance of the circuit down below, where this unknown capacitance is called C5, is equal to 2.56 microfarads. All right, so I'm just going to combine them, and I'm going to do the same thing that I did for circuits that were resistor circuits. I'm going to look for obvious combinations of things that are in series or in parallel with each other. So if I look here, are 1 and 2, are those two in parallel with each other? Well, they're only in parallel if the top sides don't have anything in between them and they've got a capacitor in between them. So they're not in parallel. How about 2 and 4? Same thing. Capacitor 3 is in between 2 and 4. So those are not in parallel. All right. How about our capacitor 5? Is that in series with capacitor 3? No, it's not, because there's a junction in between them where two wires meet. So the only thing I can see that's very obvious initially is that 3 and 4, those guys are in series with each other because there's no junctions in between 3 and 4. All right, so these two are in series, so let's combine them. And remember, for series, we do 1 over, so it's the opposite of what we do for resistors. So C34 is 1 over C3 plus 1 over C4 minus 1. So that's 1 over 12 plus 1 over 8.35. These are kind of crazy numbers here. And I get 4.924 microfarads. And again, I'm going to keep a bunch of sig figs as I work. All right, so what's the next step? Next step is always redraw your circuit with those two combined. So I'm going to take my circuit. I've got that. Still got my 5 and my 2. And so now what's happened is that 3 and 4 combined into 1. So this is C34, C2, C5, and C1. All right, so now I'm going to look for anything that's obvious. And now I can see C2 and C3, 4, those are in parallel because there's nothing but wire at the top, nothing but wire at the bottom. C1 is not in parallel with them because if you look here, I've got C5 in between, so I can't do that. All right, so C2 and C3, 4, these guys are in parallel. And sometimes you'll see me write that just as C2 is parallel to C3, 4, just using the math symbol for parallel. All right, so in parallel, they just add together. So combine 2, 3, and 4 is equal to C2 plus C3, 4. So that's 4.25 plus 4.924, and I get 9.174. Funny looking 4. Let me do that again. 1.74 microfarads. Okay, so what do we do now? Draw it again. All right, so now let's see. So I'm coming out. I got my C1. Still got my C5 up here. And then I've got this 2, 3, 4 is all 1 now. So I've got C2, 3, 4. So now I look at my circuit again. I say, well, what do I have? Are C1 and C2, 3, 4, are those guys in parallel? No, they're not in parallel because I got another capacitor in between them. How about C5 and C2, 3, 4? Well, those guys are in series because there's nothing but wire in between them. There's no junctions. So these guys are in series. So now I've got, let's see, C2, 3, 4, 5 is going to be equal to, I've got 2 of them in series, so I do 1 over C5 plus 1 over C2, 3, 4 to the minus 1. So I'll plug in my numbers. 1 over 2.56 plus 1 over 9.174 to the minus 1. And I get just over 2.001 microfarads. You notice when I'm doing my calculations here, because all these capacitances are in microfarads, I'm not putting the times 10 to the minus 6 when I do my calculations. I'm just putting the unit of microfarads at the end. So it's only if I were to calculate the charge or the voltages that I'd have to put in my 10 to the minus 6. All right, we're almost done. We're down to 2. All right, so now I've got my C1. And I've got one other capacitor. And again, like I did for the resistors, I could put it anywhere on this bit of wire here. So I could put it up here, or I could put it down here, wherever I want. It's like a bead on a wire. I can slide it anywhere I want. If I put it here on the right side, it's more obvious what the relationship is. So this is C2, 3, 4, 5. You can see there's nothing but wire between the top, nothing but wire between the bottom. So these guys are in parallel. So now my next capacitance, which I'm going to call C total because it's going to get me down to my last resistor, C1 plus C2, 3, 4, 5. C1 is 7.22 plus my number 2 from my last calculation, get 9.221 microfarads. And now I go back and I look at my problem. Let's see, all of those numbers had 3 significant figures, so I'm going to round that off to 9.22 microfarads for my final equivalent capacitance. So you do the same sort of steps that you did for resistors. Simplify it one combination at a time. Just remember that capacitors add up oppositely. So in series, you add the inverses. In resistors, you add, in resistors and series, you add them directly.